Okay, this is the second video in your series of stoichiometry videos, and this one I'm going to start introducing the chemistry behind the stoichiometry. So go ahead and press pause really quick and make sure you copy all of this down, and when you're done, press play. So stoichiometry, also abbreviated as stoic, just because that's a mouthful, is the study of the ratio between two substances in a chemical reaction. Now notice here I have 1, 2, 3 things, but when we're looking at stoichiometry, we only ever look at 2 at a time. Okay, now sometimes we're solving multiple things in a problem, but each time we only use 2 things. Whenever you're dealing with stoichiometry and a chemical equation, it has to be balanced. Right now, it's not balanced. I have 2 nitrogens here, 1 here, I have 2 hydrogens and 3 hydrogens. So before you can even start a stoichiometry problem, it must be balanced. I'm going to go ahead and balance this. If you're still confused on how to balance, I have other videos on balancing that you can watch. You can go to tutorials, anything like that that you need. So this is now balanced. First thing is realize that if there's not a number here, it really means there's a 1. If it helps you, put a 1 there so that you see it, so that it's there. And we're just going to relate 2 things at once, talking about ratios. This 1, 3, and 2, it means for every 1 of these, I need to add 3 of these to make 2 of these. If I don't have 3, I can't make this work. So you have to have that base ratio. This is the smallest ratio it could be. Now I could have 5 million of these and 5 million of these, and I can determine how many of these I can make. But the base ratio is 1, 3, 2. And we're going to be working a lot with that base ratio. Now the first thing is that you need to realize these numbers, 1, 3, and 2, we've called them in the past coefficients. They are still coefficients, that is still the term for them, but they also mean something else, and it means the quantity of moles. So we're going to look at our mole ratios here. Just so I can put it in word form, so I can show you, if I have 1 mole of N2, I would have to add 3 moles of H2 to create, so that's the arrow, right, to create 2 moles of NH3. So that's how it looks in word form. You basically just put the unit moles in there and you're good to go. With stoic, we only compare 2 things, so I'm going to show you what that looks like. We're going to create our first mole ratio, and we're going to look at nitrogen, N2, and we're going to create a ratio with hydrogen. It is as easy as looking at these numbers in front and placing them in what looks like a fraction, but it's not. Okay, so here's number 1. I'm going to put 1, but that means a mole, so I'm going to put mole, and then N2. And then underneath that, I'm going to put 3 mole H2. Okay, that's our first ratio. That says for every 2 moles of N2, I need 3 moles of H2. With ratios, they're not fractions. With ratios, you can actually flip them. And you can put 3 moles of H2 on top and 1 mole of N2 on bottom. So I literally just flip that. The purpose behind flipping it is when we go to solve these problems, we may need the flipped version, but we'll get to that later. Now I'm going to switch to green. And if I want to compare nitrogen to something else, like NH3, I can do that, and I can create my mole ratio. So for every 1 mole of N2, I would get, notice that I would get it this time because I'm producing it, I would get 2 moles of NH3. Again, I could flip that. With some chemical equations, you have tons of mole ratios that you can get, and with some, there's only a few. So the only thing that I have left here that I haven't compared, right, because I've compared these 2 and these 2, is to compare H2 to NH3. So with that, it would be 3 moles of H2 to 2 moles of NH3, where you can flip it. So I can get 6 ratios total, but it's really just 3, and then it's flipped. So what I want you to do is I want you to solve the mole ratios for this given equation and then get checked off by your teacher to move on to the next stage of this assignment. So get all of your